Biomedical engineers. Previously, the work of a doctor and an engineer were separate. One was thought to be only people-oriented, and the other simply mechanical. However, the biomedical engineer is a good example of how times have changed. Biology and engineering bring together the life sciences and physical sciences to find interesting new ways of dealing with medical problems.
A biomedical engineer does various types of things, but essentially they use engineering principles to both understand how the human body works and also to design things to help with the medical treatment of disease.
Rehabilitation engineering is one of the rewarding ways to use this combination of skills and knowledge. Helping people who have disabilities resulting from accidents, birth injuries, or stroke is the primary focus of many biomedical engineers.
I take engineering principles, the different types of mathematics that are involved in engineering, and I try to use those principles to understand how various things in the body work. And my specific focus is on blood flow in the cardiovascular system, or in your heart and in your blood vessels.
They may develop home modifications so that people can be more independent, design programs for computers to help in communication, or make adjustments at work sites for those with special needs.
My interest in biotechnology and specifically prosthetics began about 5 years after I had lost my hand in a car accident. I wasn't too satisfied with the technology that was available to me at the time, and I had a background that was mixed in engineering and biological science, and I thought that I might be able to develop a device that would offer me some increased capabilities, allow me to perform on the high end. So I started to design a device after doing some research on what had been done that would more or less satisfy the needs that I had.
Perhaps you know someone who wears an artificial limb or prosthesis, or someone who has a defibrillator implanted in his chest to regulate his heartbeat, or maybe someone who has received a new heart valve. All of these are the work of biomedical engineers. They may research and design special equipment in the laboratory, or inspect, maintain, and supervise the repair of this equipment.
It's a good field for people who have the urge to help someone, but want to be mechanically inclined to actually make the machinery. You don't have to be a doctor to help someone. You don't have to be a nurse to help someone. You can use your math and science skills.
This model essentially reproduces how a particular chamber in your heart works, and we use this to study the dynamics of these heart valves.
As in all sciences, an inquisitive and logical mind that also likes to create solutions to problems regarding people's health are qualities needed to pursue this field.
It is challenging because you have to work in very many different fields. You have to know engineering, plus you have to know about medicine and about the body and those kinds of things. So it is more challenging than I would say just a traditional engineering field.
Being attentive to detail, willing to stick with a project until it is completed, and understanding the need to work quickly are also important. Because the biomedical engineer often works in a laboratory as part of a team, good people skills are a must. Some biomedical engineers work as consultants. They may assist directors of healthcare facilities in deciding what instruments and equipment will best meet the needs of their patients and staff. Other career directions in this field include teaching medical staff about new equipment, designing medical equipment in private industries, or working for hospitals and other health service organizations.
Somebody with this kind of training can go to work for a medical device company. So what they do is they actually design the valves or imaging systems, diagnostic systems, prosthetic devices, artificial hands, artificial knees, things like that.
The field of prosthetics right now is one that's really quite wide open, and from the form of traditional bioengineering right down through prosthetic technician work. There's quite a demand for people to get involved in the design of components as well as the fabrication and manufacturing of artificial legs and arms.
A strong background in math, physical and life sciences, and computer skills will prepare you for pursuing this career. Some job duties include designing programs for computers to aid those who have communication difficulties, making adjustments at work sites to help those with physical disabilities, teaching medical staff about new devices and how to use them, and researching new theories, medical devices, and how to apply them. The education for a biomedical engineer requires an integration of engineering, physical and mathematical sciences, biomedical sciences, and clinical application. A bachelor's degree will allow for careers in industry and medical centers. Those with a master's degree can do biomedical research, design projects, or hold more responsible positions, such as that of a project manager. Those with a PhD primarily do research. Earnings range between $35,000 and $80,000 per year, depending on the degree attained and the place of employment. The job outlook is considered good. There has generally been a decline in research grants and government funding, but other job opportunities can be found in science writing, teaching, consulting on public policy, and patent law. For more information, contact the Biomedical Engineering Society at Box 2399, Culver City, California, 90230, or visit their website at www.mecca.org/BME/BMES/society.